Hello everyone, in this video I'll give an introduction to Newton's three laws of motion. Isaac Newton was probably the world's very first physicist. If we consider physics, the science as we know it today, he was truly the first. He established his three laws of motion. The first law states that an object stays at rest or at a constant velocity unless a net force not equal to zero acts on it. The first law is the law of inertia, which states that an object with mass tends to continue at the rate that it was going before. If the object was at rest, it will want to stay at rest. If the object was moving at a motion, it will want to continue at that motion unless a net force acts on it, and then it changes direction or changes the velocity and so forth. So the first law is the law of inertia, and so forth. The second law states that force equals to mass times acceleration. So here the first law states what needs to happen for an object to accelerate. The second force shows what the equation is for acceleration, for the net force. So force equals to mass times acceleration. So the greater the mass of an object, the greater must the force be applied to it in order for it to accelerate a given amount. And same thing can be said the other way around, like to slow down an object with heavier mass, it takes more force, because the greater the mass of the object, the greater its inertia. So it's not just speeding up, but also slowing down. The greater the mass, harder it is to slow it down and speed it up. And the third law states that every action has an equal and opposite reaction, meaning if you kick with your foot a soccer ball, the same force that you applied on the soccer ball will exert on your foot. But the reason why the soccer ball will accelerate more than your foot is because the ball has less mass. This is also why it's not a good idea to hit a rock, because the same force you exert on the rock would exert it on you. So when you have the moon and the earth, the same force that the moon exerts on the earth exerts on the moon. Forces are equal and opposite. This is the laws of interaction. Examples. The arrows indicate the direction of forces. In the first two examples, the object remains at rest or at constant velocity. In the example on the left, there's no force. So the net force is zero. So the object, if it is at rest, will continue rest, and if the object is moving at a constant velocity, will remain at a constant velocity. On the object on the right, the forces are balanced. The left force and the right force completely cancel out, and the object has a net force of zero. Once again, if it's at rest, it will remain at rest. If it's moving, it will remain moving at a constant rate. In these next two examples, there is an acceleration, which means that forces are not balanced. On the figure on the left, there's a net force towards the left, so the ball will accelerate to the left. On the particle on the right, you notice that the left force is greater than the right force, which means that there's going to be a net acceleration to the left. The equation for force is force equals mass times acceleration, Newton's second law. Force is measured in newtons, mass is measured in kilograms, and acceleration meters per second squared. Example 1. Mass of red particle is 3 kilograms. There is a 10 Newton force to the right. So using F equals ma, 10 is the F, 3 is the m, and what is a? So 10 divided by 3, 3.383 meters per second squared. The acceleration is 3.33 meters per second squared. To the right, acceleration has both magnitude and direction. Example 2, the mass of the red particle is 2 kilograms. There's a force of 30 newtons to the left and 20 newtons to the right. So the net force will be 30 minus 10, 20 newtons to the left is the net force. 20 divided by 2, which is the mass of the particle, gives you 10 meters per second. The acceleration is 10 meters per second to the left. And of course, these are two simple examples which can get more complex and will get more complex in the next few videos. So here's an introduction to Newton's 3 laws of motion. Thanks for watching.